All right, guys. Now, what we have for the lesson of today is basically a continuation of the assessment. Now, please note that the assignment that I gave you recently to do is going to be recorded. I mean, it's going to form part of the final marks you guys are going to get, because for this term, that is this second term, we have our assessment divided into three. We have got assignment. You must do an assignment at least. Then you must also do one investigation, and then later you must do a test. So when we add the marks you have got in the assignment and we add it to the marks you have got in the investigation, then we add it to the marks that you have got in the test that you will be doing all together. That one will form the school-based assessment for your grade 8 this time. Okay, so now the investigation that I'm going to give for you is going to be based on this topic of numeric and geometric patterns. We have had a number of lessons already on numeric and geometric patterns, and as I indicated much earlier on, I said the topic or the chapter of numeric and geometric patterns will help you to learn how to create on your own, recognize by yourself, describe, extend, and make generalizations about numeric and geometric patterns. Now, these patterns also allow you to make predictions. Okay, we had discussions on this already. You can predict how things will be if you already know the pattern of how things are happening right now. Okay, and you can also use diagrams, flow diagrams, tables to help with the what? To help with these predictions and descriptions and recognitions, and things like that, the extension. Now, as also we indicated a little bit earlier on in some of the previous lessons, we saw that this numeric and geometric patterns, well, takes into consideration two things. That is the first section being the term-to-term relationship in a sequence. Now, we had already seen that a sequence is formed when numbers with similar patterns, okay? When we have a list of numbers with similar patterns. So that is how we get what? That is how we get a sequence. Okay, now we saw this in one previous lesson that a sequence is formed when we have a list of numbers with a similar pattern. And now we also discussed how these patterns can be generated. Okay, now there are so many ways of generating the pattern. One of the way in section 1, that is 4.1, is the term-to-term relationship in a sequence. Now, with the term-to-term relationship, what we have is that if you are given, for example, a number, okay, like say 2, and the next number is 5, well, what we have for this is that you must add something or subtract something, or maybe multiply or divide the first term by some other number to get the second term. So in this case, we are using one term to find the other term. You see, that's the reason we are calling it term-to-term relationship. Okay, so with the term-to-term relationship, what we have is that you use the term which you have been given, which in this case is 2. Now, just a quick reminder, this list of numbers which forms a specific pattern is called a sequence, and each number in the sequence is called what? The term, with the first number being the first term. Now, the thing here is this. If you look at sequence A, The first number is 2. The first term is 2. The second term is 5. Possibly something was added onto 2, and that was 3 to get 5. So you see, the relationship is that we have to do something on one term to get the next term. Now notice that to move from 5 to 8, if we have to get 8 from 5, we also have to add 3 onto 5 so that we get 8. And when we add 3 onto 8, we get 11. Adding 3 onto 11, we get what? We get 14. So the whole deal here is that we must add something onto the term already there before we can get the next term. Meaning if the last term here is 23, to get the next term, we must add 3 to it. So you see, this relationship is called term-to-term relationship of a given sequence. Okay? And now that even extends to the second question. So you see in the second question, sequence B, we have 4 followed by 5, then 8, then 13, then 20. You see that? So there is a pattern being followed here. And before we find the next term, we must know the first term. So notice that from 4 to 5 in this case, 1 was added onto it. Then now, here we have 1. Then from 5 to 8, 3 was added. Then from 8 to 13, you see what was added? Well, 8 to 13, 5 was added. So the first being 1, the second being 3, the next being 5. So it's like we are supposed to be adding 2 onto the number which is added onto the previous term. You see? So the whole relationship here is that before you find the next term, you must know what happened to the previous term. That way, we are dealing with one term to the next, a relationship we call term to term. The same thing which also happens here. Here we have 1, next is 2, next is 4, next is 8, next is 16. Very much like to find 2 from 1, we have to multiply 1 by 2. Okay, this time adding cannot work, conveniently. So we have to multiply 1 by 2, we get 2. When we multiply 2 by 2, we get 4. We multiply 4 by 2, we get 8. See that? And to multiply 8 by 2, we get 16. So you multiply the previous term by 2 to get the next term. This type of relationship is called term-to-term relationship in a sequence. But as we have it here, there are times when you have to deal with what? When you have to deal with position-to-term relationship. Now, position-to-term relationship means you have to engage the position that the term is representing. Okay, you have to engage the position that the term is representing. For example, we had seen the number in the sequence is what we call the term. So for example, when you look at these pictures here, we have up to 4 pictures. So one thing we have here is that in this picture, let me make it really big, like that, yes. So if we look at this arrangement, we have 2 here. Then next is 6. Then next is 9. Is it? No, 12. Then next is what? 24. Now, one thing we notice obviously here is that if 2 is the first number, okay? In fact, I just guess I have to write this down so that you can see really well what we are dealing with. Excuse me. So the first number represented by possibly 2 balls. Then the next number 6. Then the other number 12. Then the other number 24. You see that? So what I'm just trying to do here, I want to introduce a way of dealing with this. All right. So yeah. So what we have here is this. We have the number starting with 2, then followed by 6, then 12, then 24. All right, how are we going to handle this? Well, let me first write it here. So this is the pattern that we are dealing with at the moment. It's 2, then it's 2, then 6, then 12, then 24. You see? Now, if this is the pattern that we are dealing with, please note that if we decide, for example, to add a number, say, let's say we are adding, say, 4 to 2. When we add 4 to 2, okay, well, let's say the first number is 2, then we want to find out how we get the next number. So let's say we add 4. Well, we can get 6, but the question here is it going to be easy for us to keep adding 4 to get the next numbers? You see, for example, 1 to 6, when we add 4, are we going to be able to get 12? You see, this one cannot work. You see, this one is not the correct pattern. So we say this is not the what? The correct pattern. Not the correct pattern. Well, starting with a 2, what if we multiply? Well, let's check if multiplication can help. In this case, we are going to multiply the first number 2 by what? We are going to multiply it by 6, rather by 3. So let's see what we get here. Yes, when we multiply by 3, that means for the next number, which is what? Which is 12. Or to find 12, we must also multiply 6 by what? By 3. So for 6 by 3, let's see what we get. 6 by 3. You see? So you notice that from 2, instead of, well, we can get 6 after multiplying by 3. But if we multiply 6 by 3 to get 12, it won't come out. So what do? Well, we still conclude that this one is what? Is not the correct pattern. Yes. We generally say this is not the correct pattern. So what this means is that the approach of getting the next term from the previous term or from the current term, that is the term-to-term relationship, cannot work for this. What can then work? Excuse me. What can then work will be when we deal with relationship between the position and and the term. That is position to term. So let's first take this whole thing and we check with this new approach. So we say this is alternative approach. Alternative approach or method. See what comes with this. So now that way, 2 is the first term. 6 is the second term. 12 is the third term. 24 is the fourth term, you see? First term, second term, third term, fourth term, like that. Now, can we use this relationship here to help us figure out that? Well, yes, we can actually do that. Okay? So what we see here is, when we look at this type of relationship between, like to help us find the pattern, okay? So what relationship exists between 2 and 1? Is that relationship the same as that relationship between 6 and 2? Okay, is that kind of thing true? For example, you can see that when you multiply the first term by 2, you get this. When you multiply rather by 3, multiply the first term by 3, you get the second term. Multiply the second term by 3, you get the third term. Multiply the third term by 3, you get the fourth. Really? Wait, let's first see. The first term being 2. Like that. The first term being 2. So to get the next, we want to multiply the position, okay, by a number. Well, let's see this time. Which is what? Which is, we are multiplying the term in the first position by what? By 3. You see that? So that means we will multiply 2 by 3. Because 2 is in the what? Is in the first position. Then that way we can multiply now. Well, first position, this by 3, we get that. This by 3, we get that. This by 3. See that? So basically, we are multiplying the position the way you can see here. Let me just bring this down again. Right there. There we go. Okay. So wait. All right. You see? So here we have 2. 2 is in the first position. Then we have 6, second position. Then 12. What this means is that from the first position, to get the number in the second position, we have to multiply the number in the first position by 3. Then when we multiply the number in the first position by 3, we get this number in the second. Then to multiply, or when we multiply this second position or the number in the second position by 3, we can also get this other one here. Well, can we get, no, this is going to be 2. Well, seems I missed out something here. This is 2, 6. So to get 6, we have to multiply by 3. Okay. Then from 6 to get 12, we have to multiply by 2. Then from 12 to get 14, rather to get 24, we have to multiply by 3. I guess this is not a very good example to illustrate the relationship between position and term. Let me look for another example instead. Let me just put this other example, which is going to illustrate clearly these concepts. Yes. So let's say we have 1, then 4, 9, 16, and 25, like that. What we notice is that here we deal with positions. So we have the first position represented as 1, The second position represented as 4. The third position represented as 9. The fourth position represented as 16. And the fifth position represented as what? 25. Now, the question here is, what can we do to the first position? To the position, okay? To get the number. Well, what we can do here is simple. We just square, right? We just square this, you see? Then for the second position, what else do we do? We also do the same, we square. Then what else do we do? For the third position, we also what? We also square. Then what do we do for the next? Well, for the next, which is 4, we also square. Yes. Then the next is being 5, which we also do what? Which we also square. Like that. So now this type is called position to term relationship. You square the position, you get the what? The term. You square the next position, you get the next term. You square the next position, you get the next term. This type of relationship is called the term to what? The position relationship, as we have seen here, or the position to term relationship. So basically, numeric and geometric patterns will always, be moving in between that, the term to term relationships or the position to term relationship. You just need to be careful enough to examine the relationship well so that you can investigate nicely whether it is a term to term and you create a proper pattern, or whether it is a position to term and you create a better pattern. Now, this one has been what? For the introduction of the things that we have been discussing already. I wanted to do this so that I prepare you for the investigation. Now, please note that this investigation that you are going to do will cover the whole period of tomorrow. We have 3 lessons tomorrow. The first lesson starting at 8:45. So that is the double lesson. Then there is another lesson starting at 10:30. Now, this is what you're going to do. For the first lesson, which starts at 8:45, that is the first mathematics lesson, what we are going to do is you guys will be answering an investigative question. And the investigative question for the double lesson is broken down into 2. The first activity of the investigative lesson, which is the first activity is going to be, you guys are going to be having, yes, this one here. You will be investigating and extending geometric patterns on square numbers, okay? So your first investigation is going to be on square numbers. Well, what are you going to do here? Not really that much. What you're going to be doing is, for example, as it is indicated here, the question is that how many window panes will be there in type 5? So you will read the question, you analyze it, you investigate, and you write the answer here. So that is going to be our what? That's going to be the first activity. You will be investigating square numbers. The investigation, the result of your investigation, you write it here. That is the first activity. It may have part, many more parts, but this is the first thing I wanted you to see. First investigation will be on square numbers. Then the second investigation is going to be on triangular numbers. Okay? So triangular numbers are numbers, as you can see here, that form what? Triangles. So this is where your second investigation is going to be. So you will carry on investigation, you will check triangular numbers, and it will help you to answer question 1 and maybe question 2 or 3 depending on how it will appear. So yes, your investigation for the first lesson starting at 8:45 will start with square numbers. The result of your investigation, you will write them here. Okay, then in the second lesson, which is 9:20, is it? Yes, it's, let me see, your second lesson starts at what time? The second lesson starts at 9:30. Yeah, not 9:20, starts at 9:30. So at 9:30, we will then be moving on to the next investigative questions, which is what? Triangular numbers. You will have finished square numbers. You will now be going to triangular numbers. And when you are done with the triangular numbers, you will be having a break. Then after that break, you will carry on to do what? To move on to the next lesson, which starts at 10:30. So the lesson which starts at 10:30, your investigation is going to be what? It's going to be a general investigation. No longer on triangular numbers, not on square numbers, but it will be what? A general investigation. And the result of your investigation is going to be written here. So please make sure you use that time well, because this investigation is going to be part of the final marks which will appear in your report. So I've broken it down. Square numbers starts at 8:45. Triangular number starts at 9:30. Then at 10:30, you do general investigation, which is on this what? On this worksheet here. So this is what you are going to do. So please make sure you do them all and make sure you submit them as the lesson will be ending. You will be submitting them as assignment, and you will upload them right away on Moodle, and I will check from there. So this worksheet here is your what? Is your general investigation starting at 10:30. There are 3 numbers for that. Square numbers, well, square numbers do part. Square number starts with the part 1, part 3, part 4, part 5, yeah. Yes, these are additional information, okay? So square numbers stop here. It is broken down into what? Into 5 parts. So you will do the question on square numbers starting with the part 1, which is what? How many window panes will be there in type 5, then in type 6, then in type 7, like that, you see? So you will do this. There are 5 questions. 1, 2, 3, 4, and the 5th question is on the next page. You will do that. Then, well, this is just a general description for you. Then when you're done with square numbers, you will move on to triangular numbers. Triangular numbers is broken down into part 1. Part 1 is divided into A, B, C, D, E, F. Then it also has got part 2, part 3, part 4. Yes, that is all for what? That is all for triangular numbers. So triangular numbers has got 4 questions. Then square numbers also 5 questions. 5 questions, square numbers, 4 questions, triangular numbers, 3 questions, general investigation. And when you are done with it, submit your work as an assignment. By the end of the lesson, just take pictures of your question, of your answers, and you submit them, you upload them, then I will be checking them right away. So yes, I again say this is part of your final exam. It's an investigation. So please make sure you do it and you hand over or you submit your work. If you find a difficulty anywhere during the process, just send me a message on WhatsApp and I will check through. Then I will also respond to you. That is where we have to end for this lesson.